Okay, we're going to calculate some inductive reactance here. So what we have here is not resistance, what we have is reactance. And remember that XL is equal to 2 pi times the frequency times our reading here in henries, right, our inductance. So it's a function of frequency, and it's not resistance, but it's reactance. So instead of R, we're using XL. So the formula is 2 pi times frequency times L. So I were to write these out, I'm going to do 2 times pi times the frequency here was 60 hertz unless noted, 60 times 3.2 henries, okay? So if I run that, the first thing I'm going to show you is if I take 2 pi 60, 2 times pi times 60, that's 376.99. So in the future, it's fine to do 2 times pi times 60, but we could use 377, and that's probably going to be pretty good, but we'll keep there. We got 376.99. Now I need to do times 32, and I end up with, oops, I got too many things. I must fit too many. 2 times pi times 60 times 3.2. That's why I didn't hit the 3.2. And this is 1206.37. And it's ohms, but it's not resistance, it's reactance. This one here, 2 times pi times 60 times 1.6 henries. And this is going to be 2 times pi times 60 times 0.8 henries. So we can take this and we can go 2 times pi times 60 times 1.6, and that equals 603.19 ohms. And this one, 2 times pi times 60, remember that's 377, but times 0.8 is 301.59 ohms, okay? This one right here is pretty similar. The only difference here is that it's at 50, and it's 100 millihenries, so we'd be moving the decimal 3 places, okay? So this once again would be 2 times pi times 50, because it was 50 hertz, times 0.100 henries, and that is going to be 2 times pi times 50 times 0.1 equals 31.42 ohms, okay? Now, we are going to take it a little bit farther in the next one right here because we're going to get current for these, okay? And before, we've used the formula that we had, I, current, is equal to voltage over resistance. Well, we're not doing resistance anymore. We're going to say that I is equal to voltage over your inductive reactance, okay? So we got to get that first. So we can do each one of these like we just did a minute ago, where we went 2 times pi times, and this is 50 hertz, right? Times, and this is milli, so it's 1, 2, 3 times 0.01 henries. Looks like this one is going to be 2 times pi times 50 times 0.05, and this one right here is going to be 2 times pi times 50 times 0.04 henries, okay? If I go ahead and I knock those in my calculator right here, 2 times pi times 50 times 0.01, I'm going to get right here 3.1416 ohms, okay? And then this one right here, 2 times pi times 50 times 0.05 equals 15.7170. Let's go 7080. I'll go 7080. We'll go to 4 if you want. Okay. And then this one down here, 2 times pi times 50 times 0.04. This one is 12.564. Okay. So we talked that when they're in series like this, we can just add these inductances. So we could have had, you know, L total is L1 plus L2 plus L3. And so we would be simplifying into a single one right here. So we can take all these right here and we can add them up. So we went this one plus this one plus this one, okay? So I went 3.1416 plus 15.7080 plus 12.564. I'm going to come up with a total right here of 31.41 ohms, okay? So that would be my total right there. So now to get my current through here, I can take my I is going to be my voltage, which is 120 volts over my total reactance here of 31.41, okay? And if I take 120 divided by 31.41, I'm going to get 3.82 amps, okay? Now, as a side note, we could have done this because it's in series. We could have went L1 plus L2 plus L3, okay? Which would have been 0.01 plus 0.05 plus 0.04, okay? And when you add those up right there, you get 0.100 henries, okay? And then we could have taken this and we could have applied it to the formula 2 pi 50 times 0.1, just like we did here, okay? We could have combined these into the single inductor and then ran the math on it, and we would have got 3.142. And you'll notice that these are pretty close to the same right here, okay? So you can do them individually, add them up, and then divide by that. Or you can add them up first and then run the math on it and then divide by that to get your amps.